Thank you very much. Thank you to the organizer for having invited me. I'm delighted to be here. So this is going to be a talk about belief in decision making, about uncertainty. It's going to be a talk on the abstract end of the spectrum represented here. So it basically takes as its point of departure philosophy and the theory of decision under uncertainty as practiced by at least some economists. Okay? Hopefully it will go beyond that, but that we're going to get to see. And as such, there's certain, perhaps slightly tedious examples that I have to start with, so let's get them over and done with. This is the introductory part. I'm hoping to choose a less tedious version of an example that you probably have already seen. So I'd like you to consider the following decision. There's a governor, a very simplified decision. So I'm on the abstract side of the spectrum. I'm allowed very simple decisions. There's a governor who has to decide on whether to build flood defenses or drought defenses. Okay, and that's the only things he can do. And as this ever so slightly rudimentary decision table reminds you, flood defenses are really only useful against floods, and drought defenses are really only useful against droughts. Okay. So what does the governor have to go on? Well, he's evidently building these for his region or his area. What does he have to go on? Well, he has to go on the best state of knowledge of climate science at the time. And for the purposes of the story, let's suppose that the base state of knowledge of climate science can't tell him anything. So he's in a region where there's an awful lot of sensitivity to how climate change might go to so many parameters. Different models give completely different models and different simulations give completely different answers. He's taking this choice in complete ignorance of even probabilistic information. Okay? And I'd like you to compare his predicament to that of his grandfather 70 years before. Same infrastructure decision, so a long-term decision, say flood defense or drought defense for the next 40 or 50 years. The difference is that back in 1947, climate scientists could, correctly or incorrectly, rely on past data to predict future climate. Okay? In particular, they could rely on past data to predict whether floods are going to be more frequent than droughts or vice versa. Okay? And suppose that they tell this governor there's a 50-50 chance of floods being more frequent than droughts and a 50-50 chance of droughts being more frequent than floods. Okay? So what I'm like, some of you probably can see what this example is, but what I'm asking you to think about is which of these governors has an easier time? Okay? Which of these governors would you prefer to be? Which of these choices would you prefer to take? Anyone who thinks that it's the governor today who's got a tough time, right, compared to the governor in 1947, is basically exhibiting what is called in the theory of decision under uncertainty Ellsberg preferences. After this Ellsberg example, slightly different from the one that Seamus put up. So this is an example where there are two urns. One urn, you know absolutely nothing about the composition, so that's the governor today. Okay? One urn, you know that there's 50 red balls and 50 black balls. That's the governor 70 years ago. And you find that most people prefer betting in the so-called known urn to the unknown urn. That would correspond to any intuition you had that the governor back in 1947 is in a better position than the governor back in 2017. And as you are probably well aware, but I figured it was a good idea just to remind this audience, just to make sure we all know, these sorts of preferences have spawned a huge literature in the theory of decision under uncertainty, because these preferences in tandem with other natural preferences in this context are incompatible with the standard theory of decision under uncertainty, Bayesianism. Okay? What evidently counts in this talk is that not that Bayesianism is used all over the place in economic modeling, for example. What counts in this talk is that it's a standard theory it's a standard normative theory, of belief in decision under uncertainty. Sometimes taken to be the canon, or it's generally taken to be the canon of rationality for belief in decision making everywhere. Okay? And by everywhere, I mean for both types of agents, for individuals deciding for themselves, I don't know, what career to take, and for groups. Groups, society, if you want, policy making. Okay? Often, the standard canon for rationality is often Bayesianism purports to be the standard canon of rationality. So the organizer of this meeting wrote me an email telling me to be introductory at the beginning of my talk, which I'm going to do. So I thought that it might be a good idea just to remind everyone what at least this literature that I'm coming from means by Bayesianism and why it's considered to be a canon of rationality. Okay, just very quickly, so we're all reading from the same hymn sheet. So Bayesianism is often summarized as incorporating three tenets. Okay? A tenet about belief. So read normatively, the tenet says rational beliefs should be probabilities. A rational agent should be able to assign, or act as if he does assign, a single number to every event, and those numbers satisfy the laws of probability. Okay? And you can immediately see, if you don't already know, why there's going to be tension with the Ellsberg flood drought example at the beginning. It's kind of difficult for the governor in 2017 to assign such probability. Tenet 2, a tenet about decision. Okay? Rational decision makers should choose by maximizing expected utility, sometimes called subjective expected utility. So Seamus put this up, so this is really just a reminder if you've forgotten something in the last half an hour. But basically, the idea is you're maximizing your utility. You're maximizing basically the expectation of your utility given your probability. The way this is often sold, especially in this literature, the way you're supposed to understand this is in terms of belief, desire, rationality. Okay? This utility function is supposed to be a representation of the decision maker's desires or tastes. So if it's a group, this is supposed to be some sort of aggregate measure of the group's taste. The probability measure is supposed to be a representation of the decision makers or the group's beliefs. See tenet 1. Okay? So relatively simple. And once again, if you consider how this works for a second, you can easily see why there's going to be problems with the Ellsberg example, because if the governor was forced to put the governor in 2017, or the decision maker looking at the unknown and was forced to put a probability on, he'd put probability of 1/2. And evidently, that basically means you can't distinguish the two urns in terms of preferences, which is contrary to what you find. There's a third tenet of Bayesianism, which is about learning or belief update or belief formation. I just flag it to say I'm not going to talk about it here. So this talk is really only about belief and decision making. We can talk about learning kind of in discussion afterwards or over coffee. I'm not going to have time to talk about it. Okay? So that's Bayesianism. And why do people like it? Just in case anyone has forgotten why it's supposed to be the canon of rationality, I'll just put up 3 things that are often said or could be said, 2 things which are sometimes said, and 1 thing which is often implicitly assumed, which are good properties of Bayesianism, at least on the normative front. Right? So number 1, you sometimes find some philosophers talking about how great Bayesianism, what a great reasonable pre-theoretical intuition Bayesianism has. So we're not looking at representation theorems, we're not looking at mathematical results, we're just looking at the formula and we're thinking, that's a really good way of choosing. So the kind of spin people put this on this is sometimes in terms of belief, desire, rationality, as I put it before. Some people talk about pros and cons. Some people talk about weighting the outcomes by the probabilities. Some people have said this. Okay? The main defense of Bayesianism is normally of type 2. Okay? And the defense often takes something like the following form. At the heart, there's some sort of mathematical result that relates choosing according to expected utility for some probability and some utility, and properties of preferences or choices. Okay? And the essential idea is something like, if you consider these properties of preferences and choices to be rational, okay, if you think that they're good ways of choosing, then you should adopt this as a way of choosing. Okay? That's how it works. So, for instance, there's a kind of an industry of churning out representation theorems that all churn out results of this form. And if you wanted to read them normatively, you would look at these properties. You would say, that looks like a good property. So famously, Savage had the sure thing principle, which looks like a great property. And so transitivity looks like a brilliant normative property, and so on and so on. I like these properties. I'm going to like this model because that's what satisfies. Okay? Dutch book arguments. I'm sorry, Seamus, for reminding you where they come from. Dutch book arguments can be put in a similar form, right? You don't want to be open to a sure loss, and that's going to show you something similar to this, right? Apologies in advance. Dutch book is going to come back on the slides later on this. A third point to be made about Bayesianism, I think in its advantage, especially when you consider it as an account of decision-making and belief for both individuals and groups, concerns the way it deals with different mental attitudes. The story told by Bayesianism couldn't be clearer, right? On the one hand, there are your desires and your tastes. represented fully and totally by your utility function. On the other hand, they're your beliefs, represented fully and totally by the probability measurement. If I'm in a group situation, and I, for example, would like scientific experts to determine the community's beliefs, but I want the desires and tastes or values of the community to draw more widely, then I know what to do. I'm asking the experts for the probability judgments, and I'm going to be asking the rest of society for something of the order of utility judgment. Okay? So there are evidently issues there, but I mean, the initial picture is nice and clear, and you would see in general how you'd want it to go. Okay? So, and a very quick reminder of what Bayesian is and why we're supposed to like it. Nevertheless, it has problems with the sorts of behavior we started before, and I think many people in this room would agree that's a big problem for Bayesianism. If you want to help people like the governor in 2017, right? It doesn't even recognize the difference between the governor in 2017 and his grandfather 70 years ago. If you want to help him deal with the specific sort of uncertainty, whatever you want to call it, ambiguity, Knightian uncertainty, deep uncertainty, severe uncertainty, what were all the names which were given. If you want to help him, it doesn't look like Bayesianism is going to be particularly constructive. And what I'm going to present here are parts of a more general project. And the basic aim is to consider what could play the role of Bayesianism as a canon or something close to a canon of rationality or reasonability, if you want, but could also apply to these severe uncertainty decisions. Okay, so philosophical question. I'm looking for normatively valid models that could give guidance to rational decision-making and belief representation under uncertainty that can deal with these sorts of situations. Okay? And basically, for people who can't be bothered staying awake for the whole talk, I'm going to give the punchline away in the next 5 minutes. So I'm going to tell you the model I'm going to propose, and then we're going to talk about various properties of it and perhaps applications. The approach I'm going to propose is based on two things: a concept and an intuition. And I'm not claiming any particular novelty for either of them. The concept, I think, has been around even longer than Bayesianism has. So this is, by now, a relatively famous quote by the American philosopher Charles Sanders Peirce. He was someone who inspired Frank Ramsey, who himself is one of the fathers of Bayesianism. And this is him saying, if you want to represent a proper state of belief, okay, it's not sufficient to represent it by one number, as the Bayesian tries to do. You at least need something else. Okay? And what I'm going to call, the way I'm going to express this idea is as follows. I'm going to say, beyond the degree to which one endorses a particular proposition, there's going to be the degree to which one is confident in that endorsement. Okay? If you call the degree to which one endorses a particular proposition one's beliefs, the idea I'm going to try and get across here is beyond one's beliefs, there's also one's confidence in one's beliefs. Okay? And the thesis is going to be any representation of rational beliefs should be able to take account of both of these things, right? One's beliefs and one's confidence in them. Okay? It's going to be, if you want, kind of taking the idea from Peirce, slightly two-dimensional. Okay? Just note that, but by the way, this is not the only quote, right? You find similar ideas in the work of Frank Knight, so macroeconomists might like it. Keynes, so macroeconomists might like it or not like it. For some of these people, what I've called confidence, they talk about the amount of knowledge. I think Keynes talks about the weight. Evidently, the relationship between the evidence you have, the knowledge you have, and the confidence that's based on that knowledge is going to be a question of belief formation. Question of how much confidence are you justified in having on the basis of a particular amount of information or a particular amount of evidence. And as I said, I'm not talking about that issue here, but we could talk about it if we wanted to. So I'm going to keep on talking about confidence. Okay? So that's the concept. How about the intuition? Well, the intuition is going to be that evidently confidence plays a role in decision-making, has a role to play in rational decision-making. What role? Well, here's the idea. Consider how comfortable we would be about kind of big climate policy decisions being taken on the basis of climate scientists' best hunch estimates. Okay? And compare that to how comfortable you would be to climate scientists themselves taking decisions on how to wager amongst themselves on climate variables in the conference after they are, in the bar after the conference, right? So they enter in wagers amongst themselves on similar variables. How comfortable do we feel about those decisions being taken on the basis of their best touch estimates? Okay? If you have the intuition that you're not so comfortable about the big decisions being taken on the basis of best touch estimates, but it's okay for relatively small wagers to be taken on the same best touch estimates, then you seem to be accepting, at least implicitly, some idea that there should be a relationship between the importance of a decision that has to be taken and the amount of confidence that you should require of a belief for it to play a role in that decision. Okay? Or to put it in maxim form, you seem to be accepting something like, for more important decisions or for decisions with higher stakes, more confidence should be required of a belief for it to play a role in that decision. So low stakes decisions like the wager, it's okay to use beliefs, best hunches, beliefs in which I have low confidence. Whereas for higher stakes decisions, say climate policy, I might really only want to rely on beliefs in which I have more confidence. Okay? And what I'm going to be doing is I'm going to be formulating and defending an account of belief representation and decision making that is going to prescribe to that maxim. Okay? How am I going to defend it? Well, what I'm going to do is I'm going to look at all the good things that have been said about. Yeah, sure.
So what if the climate scientists have a very unconfident worry about a very high stakes, Antarctica breaking up soon? How am I interpret that sort of thought in your maxim?
So, you mean, so
they have very little confidence in, as it comes up all the time, they have a lot of confidence in the mean estimate. Right. They have very little confidence in the tails. Okay. Oftentimes, that means they don't tell anybody about the tails, which doesn't seem like the very,
If they have low confidence, if at high confidence, this is something we're going to see later. But if at high confidence they can't make any judgments, then they can communicate that fact. Okay. Right, and you might want to take that into account. Okay. In your decision making, right? That would be something kind of to use Professor Zmansky's idea. That would be something you don't know, right? At high confidence. Yeah. Okay. Right.
Well, let me just keep that in mind.
Okay. I don't know if that.
I'm still not sure the way I'm supposed to take that. Right.
Can I just jump in on that?
Yeah, sure, go.
It's amazing how much is dovetailing in the practice of assessment. So basically, if the range in terms of inferred probability is 0 to 2.6, and they have high confidence it is somewhere in that range, and they end up reporting 0.6 versus 2.6. Basically, it's like they revert to this very conservative estimate that they feel more confident that it's at least that bad, and the high end is way higher.
I'm tempted to ask, so there's going to be a bit on IPCC assessments at the end. And I think I'm going to answer your question, but I'm not quite sure I'm not quite sure I've got enough material to answer it. Yeah, sure.
Very concrete example.
Give me.
Okay, I'm building the levee in front of the city. Mm-hmm. Okay, and, well, because I'm not, okay.
Brian, you can control the questions now.
Well, that question I can answer, but the problem is I would like to present the model first because it's kind of difficult. Yeah, I can quickly go through all the slides, but yeah. So you give me,
So if a climate scientist comes and tells me and says I'm pretty, I've got high confidence that it's going to be above 1 meter.
Fine.
I'm almost sure it's not going to be higher than 2 meters. But I'm not quite sure. It may, but I'm really unconfident about it, be 2.5 meters. Mm-hmm. How high do I build? Do I pay attention to their unconfident worry that it might be 2.5 meters?
So if it's an important decision, right, you're going to have to decide which. So if you think it's an important decision that requires high confidence, you're going to use the judgment you gave me with high confidence. Okay. If you had to bet on how long it's going to survive, and you're betting 10 euros, then you might want to. Okay.
Keep going.
It's kind of. I'm answering the answer I'm going to give you at the end, but I'm hoping that by the time we get to the end, I'm going to have been able to kind of give you. This is the intuition, right? Yes, the idea.
Okay, yeah. So that's what Katie and I are thinking.
There's so much awesome background.
Yeah. So
okay, it's good because I'm hopefully going to get to the awesome background in a sec. Okay, in particular, I'll spoil for people who don't know it. 3 is going to be really important to answer the questions that have just been asked here. Okay, so these are the things that were supposed to be good about Bayesianism. We're going to take these as our desideratum, plus the fact that Bayesianism has trouble with the sorts of examples we have previously. Okay? How much time do I have left? Sorry.
So you have 15 minutes off the 15-minute warning, so you have
Okay. now I've got low confidence in whatever that was. Okay, so here's what I'm going to do. I'm going to want to quickly just set out the. I'm going to want to set out the model. Okay, in general, very kind of fast. Nothing's going to be particularly complicated. Gesturing at the model, talk about some of the defenses of the model as a rational theory, and then talk about some applications that we'll talk about IPCC assessments. Okay, so the model. We need a representation of confidence and beliefs. Okay, perhaps the first thing that comes to mind is you replace, and this is something that's been said a million times today, so I'm not going to spend too much time on it. You replace a single probability measure, a la Bayesianism, by a set of probability measures. So this is something that Professor Maskey was using this morning. Something was mentioned also this morning. Something was just mentioned and called imprecise probabilities. It seems that in virtually every domain, this idea has cropped up, and it's got a different name, and it's associated with different people. Right? In our domain, Gabon and Schmeidler, for example. So if this is the space of all probability measures, this can be a set of probability measures. Okay? And you can think of this as a representation of confidence and beliefs. You're confident in a probability judgment, say that the probability of B is less than 0.2, if it holds for all probability measures in the set. Okay? And to any set, in fact, you can easily define the set of probability judgments that hold everywhere in the set. And if you've got a judgment that doesn't hold everywhere in the set, you're not confident about it. This is a representation of confidence, but evidently it's a little bit too rudimentary as a representation of confidence, because it's binary. Either you're confident of a judgment, or probability judgment, or you're unsure about it. But we have this idea that confidence comes in degrees. We were talking about high confidence, medium confidence, low confidence, higher confidence. Yeah? So we need something a little bit more complicated than this. And what I'm going to do is I'm going to take the next complicated thing up. I'm going to try and stay as parsimonious as possible. The next complicated thing up from a single set of probability measures is a nested family of sets of probability measures. Here's how I'd like you to understand this. Right? It's a representation of decision makers' beliefs, right, of their belief state. Each set in this nested family can be thought of as corresponding to a confidence level. Those probability judgments that hold everywhere in the set, okay, are going to be those probability judgments that the decision maker holds to that level of confidence. Big sets in the family correspond to high confidence levels. You hold fewer judgments at high confidence. Small sets in the family correspond to low confidence levels. Okay? And here you can compare your confidence between particular judgments. So for instance, that's a judgment the decision maker holds with low confidence because it only holds in the small sets. That's a judgment the decision maker holds with high confidence because it holds in the bigger sets. And I can say, I'm more confident of the probability of C judgment than the probability of D judgment. And by the way, evidently, I could have done the same example with the probability of B less than 0.9, for example. I could probably found that in the big set, the probability of B was less than 0.9 everywhere. And I'd say I'm more confident in this weaker probability range. Okay, probability of B less than 0.9. Okay, and that's going to be my representation of confidence. Pretty simple. I'm going to call that confidence ranking. Okay? It's a representation of beliefs, as I already said. And it's just a nested family of sets of probability measures. We can add technical details if we want when we get into theorems. I'm not going to need them here. Okay? Also notice that I haven't assumed there's a single probability measure in the center here. Okay? You could find this is a representation of decision makers' beliefs. You could find that some decision makers do have a single probability that they take as their best hunch estimate. You could find that if you ask them for their best hunch estimates, there are going to be some events over which they can't give precise probability. Okay? But that's a kind of descriptive question, if you will. A final thing to note about this confidence ranking, which is going to come up in what follows, is that it's ordinal at the second order level. That's what the parsimony buys you. It's just an order on the space of probability measures. So in the literature that I'm coming from, there are several new representations which are cardinal at the second order level. They require numbers over the sets of probabilities. So think of a second order probability function, for example. That's cardinal at the second order level. This is ordinal, which means that if you're interested in, for example, eliciting this, at least technically you require less information. Okay. So that's the representation of beliefs. We're going to need to give a kind of the decision part. And I've already kind of given away I've already given away the intuition. We're going to see how it plays out in a second when we get to the defense. What I'm going to do is I'm just going to brute force formalize this. Nothing sophisticated, I'm just going to brute force formalize it. What does it tell me? It says, the higher the stakes involved in the decision, the more confidence is required. So it invites me to associate to each decision a level of confidence which is appropriate for that decision. Okay? But level of confidence, how do I represent that? That's the sets in that nested family of sets I was talking about. That's the sets in the confidence ranking. So what I need to do is I need to associate to each decision a set in the nested family of sets. Okay? And I'm just going to take a function that does that. Okay? This is going to be subjective, a subjective parameter, property of a decision maker. I'm going to say plenty about it later. Okay? I'm going to call it a cautiousness coefficient because I don't like short names. And it's going to be defined in such a way that for higher stakes decisions, this set is going to be larger. Okay? And I'll pass the technical details. So, and that corresponds to the idea that higher stakes decisions, the confidence required is larger. What does that give me immediately? It gives me a family of decision models. All of them have the following form. They have 3 subjective parameters in them. The Bayesian utility function, I'm not saying anything about that. You want to take that as a GREGHEC function, that's fine. The Bayesian utility function or anything that works on outcomes. Confidence ranking, which, as I already said, is a representation of beliefs and confidence in beliefs. Cautiousness coefficient, if you're interested, do not fall asleep because we're going to be talking about it in about 5 minutes. And they all define, and all of these decision models, they define preferences or generate evaluations in the same general way. They basically assign to every act the utility values of the outcomes of the act, and they pick for every act a set of priors, a set of probability measures. The set of probability measures which is appropriate for choosing with respect to that act according to the cautiousness coefficient. And then they're going to use a decision rule which takes these 2 things as inputs. And as we've already seen, this is one of the things that Seamus showed us previously, there are plenty of decision rules that do that. Right? So this slide is almost identical to a slide in Seamus's talk. So you could, for example, say, plug a decision rule in that says, this is what Seamus called maximality, in this literature it's sometimes called unanimity. One act is preferred to another if it's got a high expected utility for all probability measures in the set. Okay? Or you could look at the worst expected utility over the set. Or you can look at some mixture of the worst and the best, blah, blah, blah. Take any one of these in, plug it into this sort of framework, you get a confidence-based decision model. Okay? And that's the proposal as far as decision models go. I'm going to be relatively agnostic as to which one of these I like. Okay? So once again, I'm not going to try and sell one particular decision rule. I'm selling the family or kind of a general approach or a procedure, whatever you want to call it. Okay, so let's talk about the defense and the consequences of this. Right? And the first thing I'd like to do is give you an example, like a slightly more concrete example. Okay? Where coming from an abstract side, you know that concrete isn't very concrete at all, but relatively more concrete than what I've been saying. So what I'm going to do for the first case of reasonable pre-theoretical intuition, I'm just going to look through I'm just going to take one of the rules on this slide and talk a little bit through what the confidence-based model would look like and compare it a little bit to the rule. Okay? So that's what I'm going to do. I'm going to see whether we've got any reasonable pre-theoretical intuition. Since I started from a maxim, there'll be no surprise that we do. Okay, so let's take the maximum expected utility decision rule. I'm guessing most people know it. You just look at the worst case expected utility over a set. And in the standard version of the rule, there's a fixed set. That's the imprecise literature, probability literature that Seamus was talking about. As far as I understand, that's similar to the sort of setup that was discussed this morning. Okay? So what happens if you take the confidence-based version of that? It's exactly the same, except that this set is now variable. It depends on the decision at hand. Okay? So if the decision is a low-stakes decision, the set's going to be small. If it's a high-stakes decision, the set is going to be relatively large. Okay? So what is this rule doing? It's basically saying, well, if for higher stakes, you're really only going to be relying on beliefs in which you have sufficient confidence. Okay? If you don't have many beliefs in which you have sufficient confidence at high stakes, okay, if you've got nothing to say, then that set's going to be big. And you're going to be pessimistic or cautious. But the pessimism is moderated here. It's moderated by 2 things. The amount of confidence you have in your beliefs and the importance of a decision at hand. If it's a low-stakes decision, this set's going to be relatively small. You're not going to be very pessimistic. If it's a high-stakes decision, but you're very confident about the relevant issues, that set's going to be relatively small, and you're not going to be very pessimistic.
Clarification. Sure. What do you mean by higher stakes versus lower stakes?
Great question. And basically, whatever you want to mean by it is the answer. So there's... So essentially, the stakes that are going to be involved in the decision are going to be a judgment on the part of the decision maker. I'm going to take it as part of a value judgment. Okay? So there's going to be a version in this model where the decision maker can turn up, tell me what he wants, what he thinks a state kind of sorry, I'll say that again. There's a version of this model where the decision maker can turn up, he tells me what counts as higher stakes and what counts as lower stakes, and all the machinery is going to run. There's another version of this model for economists where I know nothing about what the decision maker thinks are high stakes or low stakes. I'm going to get out this D function, which is a function noticed from acts or from decisions to sets in the nested family, to sets in the confidence ranking. Okay, I'm going to get this D function out, and I can kind of read off, or I can elicit, as it's sometimes, or reveal the stakes from the decision maker's preferences. So whichever version you like.
So, what I'm concerned about is you start off with, when I think we get the conceptual separation between the preferences and the utility function, and the separation is
going to be in 5 slides time.
Yeah, but the problem in defining stakes is there are some ways of defining stakes that would depend only on the utility function, and then you would maintain the separation from beliefs. But I can think of some ways of defining stakes which seem natural to me, which would involve both the utility function and the beliefs, and then you've lost your separation between them.
What really counts to me is that in particular cases, this D function is going to be defined separately from beliefs. Okay. If you come in with a particular stakes rule, which is going to mix in beliefs and kind of, you say your stakes rule is I'm going to use the decision maker's beliefs and the decision maker's utility function, and you kind of impose that mixture, then we're going to have separation modulo that. If you don't tell me anything about the stakes, but he's in fact doing that mixture, then we're going to have the D being separate, except that in a certain sense, the dependence on the beliefs is going to be built in by the fact that he has one fixed set of beliefs. I don't know if that's particularly clear, but you could try and define it in a way to ruin the separation, but it isn't going to work if you take the general result that doesn't take stakes as an input. That's clear. Should we talk about it afterwards? Because I'm talking about results that I'm not gonna present, so it's kind of difficult to get into detail. So what do we have? We have the idea that basically you're minimizing. So this is now I've lost my train of thought. Yes, this is the confidence version of the max min expected utility model. That's not as pessimistic, because the pessimism is mitigated either by, or is moderated, basically say either by the stakes or by the amount of confidence. Okay, so if you wanted to put it in terms of a slogan, it's basically a rule that says choose boldly if you have sufficient confidence for the decision at hand, and choose cautiously if not. Okay. And I would submit that if you look at the theory of decision under uncertainty literature, there are very few non-Bayesian rules that correspond so closely to plausible maxims of this sort. In particular, it does better than the standard maximum expected utility rule, because that rule is often criticized for being too pessimistic. Whatever, if the stakes are high, okay, in many examples you have a natural idea of what stakes are. We'll see one in a second. If the stakes are high and you use a big set, then you're going to use the same set when the stakes are low. Okay? And that's often criticized here. In a certain sense, that's partially mitigated that problem. Okay? And in the same way as the standard max-min expected utility model can accommodate elsewhere behavior, so can this one. Now how much time I'm kind of, okay, let's talk about the choice theoretical consequences very quickly. I'm not going to show any representation theorems. What I originally thought about doing was just to give you a flavor of the central choice theoretic property of this model. Okay, there's one property that's going to be weakened with respect to, for example, the max-min expected utility model or other fixed set of probability models. And I want to just give you a flavor of what that property is. And my idea was to show you it on a Dutch book. But fortunately, I can go a little bit faster because Seamus has already shown us what Dutch books are 5 minutes ago. So Dutch books are situations where you're being asked to price bets. Okay? So this is a bet on some event A. I'm out of time, so I'm going to skip the joke on what the event A was supposed to be. And you're willing to pay at most a certain amount for this bet. Okay? And just to kind of remind you of the terminology, that's the stakes. How much you can win are the stakes. That's I haven't used the word stakes. That's the word that's often used in this literature. And in this literature, you call this the betting quotient. Okay? The fraction that you're willing to pay for the bet at most. Okay? And as Seamus said, the idea is that betting quotients indicate beliefs. Okay? And the idea of the standard Dutch book argument is supposed to show you that some conditions on bets, like no, what was it? Betting, no sure loss, no set of bets which give you a sure loss, is equivalent to basically the betting quotients being probabilities. This is a reminder of what happened in Seamus's talk. And another reminder of what happened in Seamus's talk, it was noted that one of the things that's often assumed here is that the highest buying price is the lowest selling price. There's a point where you flip between wanting to buy the bet. There's a price where you flip between wanting to buy it and wanting to sell it. Okay? And as Seamus pointed out, you drop that, you're not going to get single probabilities, you're going to get sets of probabilities, or something similar to sets of probabilities, depending on the other conditions you use. Okay? So this is a reminder of Seamus's talk. So the question is, what more do you have to do to get to a confidence ranking? The sort of confidence-based model that we were talking about here. Okay? Well, here's the property you need to weaken. Okay? Property that I'm going to call stakes independence. And it basically says that the betting quotients are independent of the stakes. Okay? So in this Dutch book example, it's very clear what that means. It means that if you're willing to pay 2.5 euros for a bet where you can win 10 euros, then you should be willing to pay 2.5 million euros for a bet where you can win 10 million euros on the same event. Okay. So some people might think that's not a rationality condition. You might think that's a technical condition of the theorem, right? If you think that's not a rationality condition, if you think, well, I'm okay with paying 2.5 euros for my 10 euro bet, but I wouldn't go that far for my 10 million euro bet, then you might want to drop that. And you already know what you're going to get. If you drop it, you get confidence ranking, if you drop it the appropriate way. Okay? And I've done this on a Dutch book, but you can do this on you can do this in the max-min version, you can do this in unanimity version, you can do it in the Anscombe-Marmon setup, you can do the full thing, and you basically get the same conclusion every single time. To get from Bayesianism to a set of probability account, there's some axiom which corresponds to that buy-sell correspondence, kind of some precision axiom you have to drop. And the other axiom you have to drop to go for, or weaken, to go from here to the confidence-based account is an axiom that basically says your preferences are independent of the stakes. Okay? So the question is, we want to evaluate this approach choice theoretically. You want to evaluate this property, stakes independence. If you think it's a rationality constraint, then you're not going to like this approach. And you're going to want to stay with, for example, a single set of probabilities approach. Okay? If you don't think it's a rationality constraint, then basically you have all reason to slightly generalize from here, allow yourself more grades of confidence, and go to the confidence-based approach. 1, 2, 3. Final point in the desiderata was about the roles of different mental attitudes. And this is something that I said we'd come back to, so let's talk about them. There are 3 elements of this model: a utility function, a confidence ranking, and a cautiousness coefficient. So the first one is the standard interpretation, Bayesian desires over outcomes. The second one is supposed to be a representation of beliefs and confidence in beliefs. And the final one, well, what's the interpretation of that? What is it? Just a quick reminder, what does this hideously long named thing do? It assigns to any decision the confidence level deemed appropriate for that decision. Okay? So you can imagine 2 decision makers who, for a given decision, one of them thinks it's okay to use beliefs with lower confidence, and the other one thinks, no, I'm going to ask for beliefs with higher confidence. The difference between these decision makers is that the first decision maker who's allowing beliefs with lower confidence, he's more willing to choose on the basis of limited confidence in a decision of that importance. Whereas the other decision maker, he's more averse to that. Okay? So this seems to be capturing is some sort of attitude to choosing on the basis of limited confidence. So a taste or value parameter. Okay? And you don't just have to look at the way the model is constructed to see that. You can use comparative statics tests of the sort that are sometimes used for similar things in the decision under uncertainty literature, right? So You can borrow from that literature a preference-based definition of something called attitude to uncertainty, uncertainty aversion. If anyone's ever heard of risk aversion, this is the uncertainty equivalent of that. And some people can ask, well, what does that correspond to in the model? If one person is more uncertainty averse than another, what difference is there going to be in the model? Okay? In the appropriate setup, it turns out to be a difference of the cautiousness coefficient. In this literature, what you often take as conclusion is, well, this captures the attitude to uncertainty. And normally, you think of attitude to uncertainty like risk attitude as some sort of taste or value. So that would seem to corroborate the interpretation of the cautiousness coefficient as being an attitude, as being some sort of attitude or value. Okay? So to come back to the separation issue, we do seem to have a clean separation of beliefs and tastes here, right? Or beliefs and values here. Except that unlike Bayesianism, we have one thing that represents beliefs and two things that represents different types of values. The standard utility function and this attitude to uncertainty or attitude to choosing on the basis of limited confidence or whatever you want to call it. Okay? I may as well point out that that's something which is relatively rare in this literature. So famously, the maximum expected utility model, like quite a lot of other non-expected utility models, doesn't support such a separation. So if we take, I cited a result here. If we take the similar result for the maximum expected utility model with a single set of priors, it turns out that this aversion to uncertainty corresponds to a particular relationship between the sets of priors. So let me just remind you what that means. We're supposed to think, this is a taste. So this set of priors reflects tastes of a decision maker. But these sets of priors were also supposed to represent his beliefs. Okay? So it seems to be doing two jobs, representing partially his beliefs and partially his tastes. That's an indication that it's not separating tastes for uncertainty from beliefs. Okay? If you want to see it in an example, imagine you had two governors in the example we started off with. One had a smaller set of priors than the second one. Why does he have a smaller set of priors? Is it because he has further information or stronger beliefs, or is it because he's less cautious? Right? The point is that the maximum expected utility model and several models can't decide that question, okay? Or even properly represent the possibilities, in fact. Okay? And that might have consequences for elicitation. If you ask them for sets, you're never going to know whether there's some cautiousness or some value judgment which is hidden in there. I don't think I have time for that. How long do I have? I'm not taking the question. If I have 7 minutes, I'm not taking the question. Sorry. No, but either you give me another few minutes at the end. Or... Fine. Okay, so quick summary. It ticks all of those boxes. To cut a long story ridiculously short. Okay? It ticks all of the boxes, as long as you're willing to accept that stakes independence isn't a rationality constraint, and as far as I understand, perhaps there's at least one person in the room, namely myself, who doesn't think it is. Okay, I'd like to turn to applications because these were one of the things, these were the questions that came up. So this is joint work with Richard and Casey on IPCC's uncertainty language. So we're talking about assessment. And as at least some of you in the audience know much better than myself, the IPCC has a codified uncertainty language that it uses to communicate uncertainty that evolves from report to report. And what we're going to ask in this question is how can statements formulated in that language be used to inform decision-making on climate policy, okay? Or any decision-making for that matter. Okay? And here are two elements of the last language, the AR5, from a few years ago. Okay? One of the metrics that are used is something called confidence, their word, not mine, which is some sort of summary of the evidence available and the agreement among experts, and importantly is expressed qualitatively in terms of 5 qualifiers going from very low to very high. Another measure of uncertainty is probabilistic, okay, and often something of the order of probability ranges. So here's that probabilistic level of uncertainty. When you read likely in these reports, you're supposed to understand that they have a probability judgment of between 66 and 100% probability. Okay? And often, but not always, these two sorts of metrics appear in tandem. Okay, so here are 2 examples. When they appear, they always appear in the same order. There's always a confidence qualifier which qualifies the probabilistic statement. So the example here, multiple lines of evidence provide high confidence that an equilibrium climate sensitivity value of less than 1%, or 1 degree, sorry, is extremely unlikely. So high confidence in a small probability event. okay, or general, this is medium confidence in a high probability event, and so on. Okay? So how can we use that to inform decision making? Okay, what would be the best way of using all the information there without requiring more information that's given? I'm guessing that many of you can see, I mean, there's going to be no surprise what's going to happen here, but just in case you didn't see it, what we have is we have a second order thing which is qualitative, ordinal, okay, which qualifies a first order probabilistic representation of uncertainty. So it shouldn't be surprising that these fit in very nicely into what I've called confidence rankings. In fact, they're precisely the information you would require if you wanted to define a confidence ranking for the beliefs of the climate science community or the scientific community. Moreover, they're difficult to connect to any other recent representations of uncertainty in the literature. And it's kind of intuitive why that's the case. Either you have a representation of uncertainty which is weaker, poorer than the confidence representation, saying a single set of probabilities. But we notice that can't account for different confidence levels. It can't account for the difference between high confidence, medium confidence, and low confidence. It can only take one confidence. Or you ask for something which is richer than the confidence representation, say a second order probability. But that requires numbers. That requires cardinal information. And cardinal information isn't being provided here. Only ordinal information at the second order level. Okay? And once you realize that there's this connection, you can start drawing some other conclusions, or you can get ideas for other recommendations. So just go through one or two. So evidently, how can IPCC assessments be used to guide decision making? The easiest answer would be just plug them into the sorts of decision models I've been proposing previously. Okay? They fit in quite nicely. Moreover, if you accept the arguments that that's a rational way or a reasonable way or a good way of deciding, a normatively valid way of deciding, then that provides a pragmatic vindication of IPCC practices. They're representing the beliefs of the scientific community in a way that we've just said was a rational way of representing beliefs. Okay? Moreover, you can think about recommendations for future use. Okay? So to just take one example, and this, I'm no expert because I haven't read all of the reports, but it seems to us, from as much as we've read, that most scientists only report at one confidence level in IPCC reports. But evidently, it makes conceptual sense to talk about your judgments at different levels. So it could well be that you have a very precise probability judgment, and you hold that with low confidence. But if you ask for high confidence, you don't really know. Yeah? Okay? So it might be an idea to allow or encourage reporting at different confidence levels. It seems also, but again, this is the sort of place where I would like to discuss this. It seems also to us that scientists seem to be the people who are deciding what level to report at. But I was just emphatic on the fact that the choice of the confidence level, which is relevant for a decision, that's a value judgment. Okay? So if anyone should be taking that judgment, it shouldn't be the experts who are supposed to be giving us the beliefs, in inverted commas. It should be society or its representatives. So we might want to rethink how the choice of what confidence level to report at is being made. Yeah, okay. We would like it to be taken. Just continuing on this point, it also looks like when scientists choose what level to report at, they're weighing up considerations of informativeness or accuracy of probability judgments. Now, as I said, we haven't read all of the reports, but we certainly haven't found anyone saying, if you ask me for my judgment with high confidence, I'm going to tell you I don't know anything. Which suggests that they're trying to make a more precise probability judgment at the cost of going down the confidence levels. Okay? But what they're doing there is they're mixing some value judgments in. They're saying it's a good idea. I don't mind going down confidence levels. I'm willing to give up confidence in order to be able to say something. Again, if there are value judgments in there, perhaps we should rethink how that's thought out. It could well be a more transparent policy to explicitly set a desired confidence level that they should be reporting at. Okay? So these are just some examples of things that kind of immediately come out of crossing this abstract, philosophically, hopefully you would agree, well-defended model of decision and rationality with practice in the field, so to speak. Okay? And by the way, it's kind of easy to see how these could turn into concrete recommendations. I mean, they suggest, for example, that policymakers could perhaps be involved in advance of the reporting stage to specify what sort of confidence levels they would like reporting to be at, right? Or you can imagine that scientists are going to be asked to report at those levels, perhaps with the option of reporting at other levels if they feel there's any other relevant information to be said to. How many minutes do I have left? There are absolutely no challenges or work in progress at all. That's the end of the talk.
Since I wasn't allowed to ask one question, I could perhaps ask two.
Ask Richard.
The first question is the comparison of uncertainty version from one agent to another in the GR data result and yours requires knowledge of U, precisely, the kernel U, not simply the order of consequences. Yes or no?
Yeah, I think so. That I can remember. Yes, I think
so. That would diminish the interest for the results, you know. The other point connects with the question raised by the gentleman before. I think you tend to interpret your model very much in the revealed preference way, saying, I'm simplifying atrociously actually, stakes are what they are given D. D implicitly reveals what the stakes are. Wouldn't it be a point, if only to communicate with the larger community, to discuss examples with some exogenously defined stakes, you know?
Okay, so on the stake issue, basically, this is an issue in which we're talking about diversification. It's impossible to diversify. Because if you say that stakes are given exogenously, lots of people understand what that means, but economists hate that, right? And if you say, I'm going to use the revealed preference if I say I'm going to use the revealed preference paradigm and get them endogenously, lots of people don't really understand why you're using the revealed preference paradigm at all. So I prefer to remain silent on the issue. You can do it both ways. I will take it as a personal preference which one you want to do. Who you want to sell to, I'm guessing, is probably, you know. So maybe next time I present, I'll ask half the audience to put their fingers in their ears when I discuss the stakes issue, and I'll just take one of them.
Yeah. Thank you for an interesting talk. I was in no danger of falling asleep, especially after you mentioned a family of nested sets, which is close to my heart and close to a central idea in infogap theory. So my question is, you talked about a family of nested sets of probability distributions, but sometimes we're uncertain about other functions like constitutive relations, Phillips curves, whatever. Could you do this whole framework where your family of nested sets is not family of nested sets of probability distributions, but family of nested sets of some other functions that I'm unsure about? Why, and to make that even a little bit more general, why or is probability really fundamental here? Or maybe it's just set theoretic uncertainty, not just. It's set theoretic uncertainty about functions that I don't know. Probability functions or others?
So until you added the addendum, the answer was definitely yes. I'm now becoming suspicious about the addendum. You certainly can. You could do it, for example, with, I mean, so I was taking the standard bread and butter theory of decision under uncertainty setup, where I assume there's a set of state of the world given, right? They kind of start when perhaps the difficult part of the problem has already been assumed away. But you could take a nested family of sets of states of the world. You could also take, and this is something I didn't mention, but you could take a nested family of sets of utility functions, by the way, and do similar things about confidence and preferences or confidence and utility, something I've done in other work. So yeah, I'm not wedded to probabilities, but this is, I felt that was the most relevant thing for this module.
I have one question about ordinal. There are two...
Sorry?
About the interpretation or use of ordinal. There are two possible meanings of ordinal. One is just to say I have higher confidence. If I put a higher confidence threshold, I get larger sets because I compare basically within a particular decision situation, I compare the confidence levels and get different beliefs depending on the level of confidence required. Another one is a fixed, I measure confidence on an absolute scale, which is ordinal. So I say high level of confidence is determined for decision situations in general across a particular situation, that's a much more demanding situation. I mean, for instance, from an economic representation theorem, you would get probably an ordinal, like for incomplete preferences, you would get an ordinal ranking of the level sets within a preference, one kind of fuzzy preference relation, but it would be very hard to link the preference, levels across situations. And relatedly, as a kind of practical question, how would I, it's one thing to determine, okay, I'm more confident in my best hunch than in some kind of wild tail event, but it would be a pretty difficult question, which beliefs am I moderately confident about?
Okay.
So maybe you can...
Yeah, so the results I was talking about, I think I needed only your first notion of ordinal, though I didn't. But I think what you're talking about is what I would have mentioned if I had got to the final challenges slide. So evidently you want to be able to talk about confidence levels kind of between people. So you're going to need some sort of way of a calibration scale for confidence.
Between situations, the minimum between situations.
Between situations or between people. You'll need some sort of cardinal calibration scale for confidence. So this is the work in progress slide. There is work in progress on that. I have learned the hard way that talking about work in progress in the last 30 seconds of a question and answer session is a bad idea. So if you want, we can talk about it a little bit more over coffee or later on. Did you have a?
Yep.
Yeah, it's better that we talk about it later on because it's quite complicated.
Okay, so having spent way too much of the last decade thinking about those likelihood confidence terms, I thought this is a really riveting presentation. And I just wanted to give two observations that I think link up with your recommendations in some interesting ways. So first, both for the formal likelihood confidence, but also for assessment more broadly, in terms of where assessment has really been challenged, it's exactly what Rob emphasized in that intervention, is that where experts have high confidence that the risk is high because there are some low probability outcomes that would carry really high consequences, the implication in the science policy interface has been to clip the tails. And that's been something that assessment has really not figured out how to grapple with. And you could say in terms of values that it is indeed a value judgment. It's type 1 error aversion that is not transparent and that's ramified by skeptics in policy. So I think that's one place where it would be fun to talk about this more.
Okay, yeah, definitely.
And the second is that there's been just a huge amount of consideration of, are those likelihood and confidence scales independent or are they interacting? And what I would argue is that they're interacting in really non-transparent ways in that experts are adjusting their likelihood, assessed probability of outcomes contingent on their confidence, and being transparent about that has been a huge challenge for a lot of this applied assessment stuff.
Okay, yeah, but that was the impression I also got. That but I think that's because as far as I see, there's a mix of what we would call fact and value judgments in the way this thing is in practice, right? So if you had cleaner or less efficient techniques for confidence and beliefs, this is the work in progress side, and a calibration scale, which that could hopefully improve transparency in the sense that you're kind of fixing the confidence bit and you're getting them only to give you the probability judgments at a particular confidence level. But again, I'm not quite sure whether we should take this to coffee afterwards or not.
One more sentence. I think where it gets really hard is because value judgments essentially span from things that are totally out there in the world of decision-making and policy through to things that are disciplinary value judgments. And drawing the line gets really, really hard.
Right. Yes, that I completely agree with. But,